All right, folks. One last thing. Sorry, the last video kind of dropped abruptly. I decided at the last minute that I was going to cut the video off there and then do this next one as a separate video. Because the second thing we talk about, the first video we talked about free fall and how to do calculations for free fall. But what are the graphs going to look like? We spent a lot of time talking about the graphs in the first unit, and we're going to continue kind of talking about the graphs here in free fall, right? Since it's accelerated motion, right? Remember what we talk about, what the graphs mean. So first of all, when an object drops from a certain height, what happens to the vertical velocity? Vertical velocity gets bigger, doesn't it? Gets faster and faster and faster. Even though it's in a negative direction, it still goes faster and faster and faster. Right? The horizontal velocity, which we haven't talked about yet, but the horizontal velocity is zero, doesn't move at all. Right? And the acceleration stays the same. It's negative 9.8 the whole time. Right? So what would the shape of a position versus time graph be of a rock free falling to the earth? Okay, just a reminder, what does the slope of a PT graph? Slope of a PT graph is the velocity, right? Okay, and if the slope of a PT graph is velocity, well, isn't the slope going to change? So if the slope on the PT graph is changing, aren't you going to get some sort of curve? And the VT graph, right? Remember the slope of a VT graph is acceleration, right? And the acceleration is the same, so we're going to have the same slope, which means we're going to get a line, okay? But the velocity is going to become more and more and more negative. So it's going to be a line with a negative slope. All right, so let me move my picture out of the way here. Move my picture over way up here. So my PT graph, if I'm dropping something from a height, then my graph is going to start somewhere up here. And it's going to curve. It's going to get steeper and steeper and steeper, but in a negative way. So my graph is going to look something along the lines of that. Notice how it gets more and more steep in a negative way, and it gets closer and closer to the ground. Right? Now my velocity versus time graph, if I'm dropping it, my initial velocity is going to be zero. But then it's going to become more and more and more negative. And it's going to look something like that. Right? Now what's the slope of this line? Remember, the slope is acceleration, and the acceleration for something that's falling is negative 9.8 meters per second squared. Right? So the next thing we would do after we practice, we're going to practice some problems, we're going to practice some graphing, then we'll look at the case of throwing something up and having it go up and down at the same time. But for now, we'll stick with this.